Let us now solve talk about Warshals algorithm. So I'll be like explaining you the Warshals algorithm. The Warshals algorithm is like the easiest algorithm compared to everything. So see here, initially we will be writing the comments like this. So three comments should be written in this. So first thing we will say the given graph is a directed graph whose adjacency matrix is given. So we will say G is a directed graph whose uh, adjacency matrix is given. Okay. Secondly, we have to write an array. What is the input array? Input array of 1 to n, 1 to n. Okay, so this is one adjacency matrix with n rows and n columns. Okay, so row and for column. So this adjacency matrix which we are talking about here, this matrix is nothing but this itself. And then here we have written the transitive closure. So return transitive closure. So what is transitive closure? So there are a few problems which I will be doing later. In that I will be discussing about transitive closure. So now first let us start. So initially the algorithm, if we start like this, so we will say r of 0. This is pseudocode, okay, so you don't have to worry. In the way of writing in computer will be different. So initially saying r of 0 is equals to 0. So now here we need three loops here, okay. For k is equals to 1 to n do. Similarly for now here I, and for j, okay, same, everything is same, 1 to n do, 1 to n do. So what we have to do here? So we will say like r of 0, right? So r of k is equals to r of k of ij. So r of k is nothing but so suppose 4 matrix will be there, right? So since we need like steps will be there. So I'll tell you which variable is for which. Ij is for finding the row by column position is equals to two things. So here we have to select minimum. So it will be r of k minus 1 of I comma j. What does this mean? Is nothing but the previous value which has already been there. If that is minimum, it should be that itself, or it should be, so I will write here, okay, because I need space. So or it should be r of k minus 1 I comma k, and I think I could have written here itself, r of k minus 1 k comma j. Okay, this whole thing is one thing, this will come here. Okay, so this is the smallest algorithm here. So just note down this algorithm. Now they are at the end we will be writing returning this return r power this k. Okay, and then we have to close. Okay, so you can either return r power n or r power k, like, so whatever the last thing it went. So let us suppose n. So because we don't know how many steps will be required, so started here, closed here. Okay, so this is the algorithm. Just write write it down better, it will be right, or you already have, I guess. So now let us start solving the problem. Okay, so here I will write the formula once again. So it said r power k minus r power k of I comma j is equals to r power of k minus 1 I j, or r power k minus 1 I comma k, and this is logical, and so both things should be there, k minus 1 k comma j. Okay, so first I will solve one matrix here, and then I will write it here, solve here, write it here. So given r power 0 is equals to the given adjacency matrix. So here it is A, B, C, D. So A, B, C, D. Okay, so given matrix. So sometimes they won't give this matrix. What they will do, they will give a graph. Okay, so what is graph and what is adjacency match? Nothing but from the graph. So graph they might give like this. Okay, something like this, like this, like this. So from this, from which path to which path, so they might return 10 blah blah and all. Sometimes they won't write also. So you just have to see like sometimes it will be directed or undirected. You have to find the path. So in Warshals algorithm, we won't be dealing with the cost and all. Okay, we'll be only finding whether this is a path or not. Okay, so just want a path, and it's not like in the minimum path or like, so we are just finding a path. Okay, transitive closure, we just want to find the transitive closure. So from the adjacency matrix, sometimes they'll give the adjacency matrix directly, or else they'll give graph. From that we have to write this. So okay, so example I'll just tell you. So this is A, B, and this is C and D. Okay, according to the given thing I'll say, so A to B there was a path. Okay, then now B to D there was a path. Okay, so A to D there was no path. So and then from the given, so it's 0. Okay, here completely, and then we had 1 0 1 0. So D to A, so D to A we had a path, and D to C we had a path. So this was the matrix. According to this matrix, so it's directed. Okay, B to A and D to C. So this is the actual matrix which we had. Graph from graph we took this adjacency matrix. So this is my R naught. So this is okay. So this is K. So now what I will be doing, the Warshalls and fluids is exactly same. So now comparing with the help of this two thing, I will be like finding the path for other places. So to get R1, so now you see here, for each place I have to do. So if I consider this place, so B to B, okay, so I is also B and J is also B, and my K is A. So I will be like B to A and A to B. This both the path from B to A and A to B both should have a path 1 1. If we get 1, then only this thing will change from 0 to 1, or else it won't change. So see here, since B to A is 0, so we won't be having any path itself. Okay, so this thing will be 0 itself. Similarly, if you have to do it from here, for B to C, if you have, so B to A anyways is 0. So if you consider all this thing, since it is 0, so you won't get anything for this part. So let us see here, because here 1 is there, right? So let us try to find for this. So that is nothing but D to B. Okay, so from D to B if you have to do, so it will be like D to A and A to B. So now see here, and also the another thing is, you can try to make it like come in diagonal, so in such a way that it's there like this. Okay, so in this and in this, so that place exactly you will be getting 1 1 1 1. Okay, so now see here, D to A is 1 and A to B is also 1, so this thing will become 1. So let me see this here. I'll not have like D to D, right? So for D to D I won't get. D to A is 1, but A to D is 0, so this thing won't change. So now the only changes which has been made here is A, B, this D. So was this, now this will become my R1. Okay, so I will remove this. Okay, so only 1 1, right? Okay, here and here was 1, so remaining was 0 itself. Okay, so I have written my R naught. So now I will write my R1, which is this, because I have to like say everything. So this is so in R naught I compared this and I got this. So here is equals to A, B, C, D. So this is 0 0 0, and this is 1 1 0 0 0 0 1. This is full 0 1 1 0. Okay, so this is A, B, C, D. So same way I will now consider this. My K is this now. Okay, now let us try to find R2 with the help of R1. Okay, now you see I have already found so now, like I said, the trick here is to find a path you should find in such a way that in this, where is 1, so okay, it should match like this. What I mean is, here like this, here 1 is there, here 1 is there. If you come like this, so here, so now with the help of this 2, both the places I will be having paths, so this can become 1 now. So that is the actual technique, like you can apply to make it like that. Okay, and also you can try to do like this. So wherever 1 is there like this, so you can try to do, okay, just let me solve. So this place, let me try to do this. So that is nothing but d to d, right, d to d. So how to do d to d? So d to d I can do like, since b is my k now, d to b and b to d. So d to b is 1 and b to d is 1. So this I can change it as 1. So here this became 1. So now let me try to like find if there are other places also which I can change to what to say. So first see here, a to b is 0 and so here a to, okay, b to a is 0, b to b is 0, b to c is 0. So only b to d is 1. So now I have to find in such a way that I can get like wherever from other nodes to d. So let me try from c to d and a to d. Why? Because if I take c to d, then I will be having b to d, so which will give me 1. Okay, I hope you are understanding what I am like. I am just trying to like talk in a much higher level. What I mean is, since in this d is having 1, okay, so b to d, d is having 1, okay, b to d is having 1. So I have to find other places which is 0 will have a to b as 1. Okay, so see here, a to b as 1 is my what to say, here a to b. So here it is 1. Okay, I won't change this, I will be only changing this. So a to d I can a to d I can do like this. Okay, so here a to d, so like that I can change this as 1. So I will remove this and remove this. So see in the remaining place where a to b is 1. So here already a to d already 1 is there and 1 is there. So like this no other places we can write. So now let me write my R2. This matrix which here is my R2. Okay, is equals to, so 0 0 0 1 1 1 1 1 0 1 0 0 1 and 0 0 0, a b c d, a b c d. Now I have to be like take this and then compare. So let me just erase this I and j, right. I'll remove this. So I'll in this I'll try to make it more clear. So my R2 is this. Let me take it from down. Okay, a b c d, a b c. Okay, so 0 1 0 1. So here everything is 1, here everything is 0, here only this is 1. So now I will be considering this. Okay, so now by considering this I have to find paths in such a way that I will be having. So see here, now let me try to find here a to a. So if I try to find a to a, so a to c plus c to a, so it is 0. Okay, so because c to a is 0, it will be 0. So here if you are like smart and see here, you can see that from R3 you cannot actually make any changes. Why? Because everything is 0 here, right. So no matter what value you take, from that value, like from c to that value should go. So c to a or c to b, c to c, c to c, all are 0. So you won't get any path itself. Understood? So you have to write just write that we are finding intermediate nodes with the help of R2. So R2 and R3 are same. Okay, so now what I will do, I will just 0 0 0, what was here? Okay, let me just erase this properly. Okay, so this was 0, right, and this complete was 0, and here this was 1, right. Yeah, it's right. So now I will consider this and then I will consider this. So now see, I have to, these many places are left. So now D, so see, let me try finding for A to A. So if I try to find A to A, so it will be like A to D and then D to A. A to D is 1 and D to A is 1. So I got and it becomes 1. Let me try from A to C. So A to C. So if I do A to C, then A to D and C, okay, D to C. Okay, so A to C is 0 and oh sorry, A to D. So A to D is 1 and D to C is 1. So this also becomes 1. How it becomes? See, A C is right. In middle you have to just add D. So A to D plus, okay, D to C. So see here, A to D is 1 and D to C is 1. So this becomes 1. So this thing is done. So now let me try to find this B to A, B of A, B to A. Okay, B to A is 0. So now putting my K in the middle, B to D plus D to A. In the middle you see B is here itself and A is here itself. Only in middle we are adding this D. Okay, so B to D is 1 and D to A is again 1. So this also will be 1. Similarly, if you see here, no matter what I take, so here it only be B, right, B to B. So only thing changes is here, this B. So anyhow, this will be same for the entire row, it will be 1 and D has all the values. So directly you can write this and this as 1. Okay, so let us now try to find a path for this C plus. So see here, since C to D is 0, okay, so we have to find C and here C to D should come. Okay, C to D is always 0. So no matter you do like D to A, B, C, D, for all the values this is 0. So we won't have any path itself over here. So finally you will write this matrix without this thing. Okay, let me just write and show here. So this I will directly write is equals to R. So you have to make the matrix again and then my R4 is equals to, in R3 you have to make this, okay, not like this. So at the end I will say, so this was 1 1 1 1 1 1 1 1 0 0 0 0 1 1 1 1 A B C D A B C D. Actually I can made you like confusing, I got confused, like I explain in a confusing way, but still I tried to cover it up. So I hope you understood the actual way of like finding. So you understood this formula, I guess, because every time same way we have to do in fluids, but here their cost will be there, here cost is not. So we are doing only 1 and 0. Their infinity and number will come. Okay. So this is the only thing I have to like say about this Warshals algorithm and how to compute this. So I hope you understood this problem. Okay, so this is one of the easiest, because the algorithm for this is very easy. Fluids, a little bit extra things will be added, only the cost things. Okay, so remaining even that will be same.